So in the last class, what we have discussed was, we have discussed that the LoadRunner tool has three components: the virtual user generator or VUGen, popularly called as VUGen, wherein you will be able to create the scripts in that, you'll be able to play back the scripts, and we also understood that creating the script happens using recording mode. Okay, we'll be able to record and create the scripts. Okay, and we'll be able to play back. But the idea of performance testing is we wanted to play back with multiple virtual users, not just with one user, but multiple virtual users. And that is possible using a component of LoadRunner called controller. So this is what we were discussing in the last class about the controller. Okay, we're discussing about the controller. So so let's say we have created two scripts and our application under test, let's assume it's a Gmail application, or AUT is application under test, which is the Gmail application, and we are doing the performance testing on Gmail application. As a part of it, let's say you've created only two scripts, and these two scripts will be created using the tool called, or the component called, VUGen. Okay, then we have executed them separately using the VUGen, and the scripts are working fine. Now, using the component called controller, we will be executing them simultaneously. This is what it is important. Okay, simultaneously as in together. And not only simultaneously, but with certain number of virtual users. Okay, so as to create the load on the application. Why we have to execute them with certain number of virtual users? So as to create the load on the application under test. Well, this is what I'm talking about, guys. Okay, so these are the two scripts. Okay, and script 1 is executed with 600 virtual users. Script 2, which is delete mail, will be executed with 400 virtual users. And these 600 users and 400 users, the controller will not be providing them. There is a component called load generator, or LG. LG as in load generator. So this 600 is provided by an LG called LG1, and this 400 is provided by a component called LG2. Okay, in other words, you can have multiple load generators depending upon the need. So we can have multiple load generators depending upon the need. Okay, so now, so the point which I'm trying to make here is the controller can be configured for the number of virtual users, okay, as you can see here, and also the number of scripts to be executed. Okay, so like this. Now the next question is, okay, so yeah, so here the check mail, this is the same picture that we have seen earlier, the controller part. Okay, we have a check mail which is 600 and the delete mail which is being executed by 400 virtual users. So this is what we call it as a check mail group. Okay, and this is what we call it as a delete mail group. Okay, and together we call this as a test scenario. This is important. I'm going a little fast here because this is something that I've explained in the last class. Okay, so these multiple groups make the test scenario. Let's take a case study. Okay, can we have a test scenario? Can the test scenario has more than two groups? Okay, that's what I'm going to talk about now. Okay, if you're wondering, only two groups could be there in the test scenario. Okay, that's what we will talk about now. Okay, the answer is no. We can have as many groups as we want. Let's take a sample case scenario wherein you have created 50 scripts for a banking application using VUGen. Okay, so let's say account summary, statement history, balance transfer, and like this you have created 50 scripts. So all these 50 scripts will be uploaded into the controller. Now you have 50 groups. Okay, we have 50 groups. All these 50 groups makes the test scenario. Each group should be having an LG and number of virtual users. These 200 users are coming from LG1. These 100 users are coming from LG2. These 50 users are coming from LG3, like that, so on. Okay. So now the next question is, why simultaneously? Why not separately? Why are we executing these scripts simultaneously? Why not separately? Again, this is something that we have discussed in the last class as well. Okay, in the real world, all these functionalities are happening simultaneously. If we go back to a Gmail application, you know, right now the time is around 6:44. At this time, which is 6:44, okay, let's consider the Gmail application. Let's consider there are 1,000 concurrent users using this Gmail application at this time, 6:44 a.m. Out of this 1,000, some of them are checking the mail, some of them are deleting the mail, some of them are composing the mail, some of them are attaching an attachment, some of them are doing a delete all, some of them are changing the password, some of them are changing the theme. Different people are doing different things. So we have to simulate such kind of situation in our performance testing, or whatever is happening in the real world, we have to make sure the same thing is happening in the performance testing world as well. Okay, same thing is happening in the performance testing as well. So we create all these scripts and we execute all these scripts at once with certain number of virtual users, so that whatever the scenario that you have created and whatever the scenario, the test scenario that you are executing, is as close to the real world as possible. Okay, so we have to simulate the same thing in the performance test as well. So we'll take a simple case study in the controller. So for a banking application, I've created 50 scripts in the Vusion. Okay, so we have created 50 scripts in the banking application. Let's see what happens. Okay, in the general world. Okay, now these 50 scripts will be created in the Vusion separately, and mostly it will be done using the recording mode. So you record all these 50 scripts and all that. Now you execute each script separately, and we wanted to make sure the scripts have no issues at all. Now at this point of time, okay, now you understand that you have to execute this test, whatever the test that you are supposed to. Let's say you have to execute with 1,000 concurrent users. Okay, overall 1,000 concurrent users is what you have to execute the script. Now all these 50 scripts are put together in the controller. Now you upload all these 50 scripts onto the controller, and you make sure that you're executing with 1,000 concurrent users. So account summary 200, statement history 100, balance transfer 150. Like this 50 scripts, you assign the number of virtual users to it, and you add all these virtual users for all the 50 groups. It should be 1,000. Okay, it should be 1,000 because the client said so in the NFR document, or in the non-functional requirement document. Client said that you are supposed to execute this test with 1,000 concurrent users, which means that each script is not with 1,000. Okay, each script with certain number of virtual users, but you add up all the number of virtual users, I think it will be 1,000. I believe it should be 1,000. Now once the test is done, you run, typically the test will be run for 1 hour. Why 1 hour, we'll discuss later, but at this point of time, just make an assumption that it is 1 hour. So the test will be executed for 1 hour. It will not be run for one iteration or 5 minutes or 10 minutes. It will be run for 1 solid hour. And after the whole test is done, okay, you check for something called response times. Okay, response times, again I will cover what is this response times probably when we are discussing about architecture, the system architecture. Okay, so look for the response times and we make sure that they are as per the SLA. SLA is nothing but what the client will give as a part of NFRs. Okay, the client said that all my response times, okay, the client said something like this. Okay, all the simple functionalities, the response time should be less than or equal to 2 seconds. For the medium, the response time should be less than or equal to 5 seconds, and all the complex functionalities should be, the response time should be less than or equal to 8 seconds. This is what my client said. Okay, now you check these response times, whatever you got for these different scripts, and make sure they are as per the SLS or as per the non-functional requirements. Okay, so this is what you're gonna do in the real time, in the real world. This is how you will do it. Okay, SLA as in what will client provide as a part of NFRs. In this example, these are the SLAs. For the simple functionalities, 2 seconds, maybe for launch functionality or the login functionality, or the medium functionalities, the response time should be less than or equal to 5 seconds. Like let's say checking the statement history. Let's say you are pulling 1 month's history. So this is like medium functionality. So these kind of things fall under medium functionality, and the response times for such functionality should be less than or equal to 5 seconds, and anything which is complex, okay, should be less than or equal to 8 seconds. So these are the SLAs, and we make sure that whatever you accomplish, okay, whatever, so the response times is nothing but how fast or how slow your application is, how fast or how slow your application is. So you will check how fast, how slow it is. As long as it is the speed is as far as less than this SLA, we should be good. Okay, this is what you do as a part of this thing. Okay, as a part of the controller. You see, sometimes not all the script pass, which means that some of the scripts have the response times more than 2 seconds or more than 5 seconds. Okay, so in my script, one script fails. Let's assume, in my case, let's assume one script fails, which means that you have to rerun the test after fixing the issue. Let's say you have executed it, and some of them have a response times of greater than 5 seconds as well. Okay, so you have to rerun the test. And one more thing, okay, yeah, the script will fail because the response times is greater than what has been told in the SLA, or the script will fail because there is some issue when you have created the script in the VUGen. So if the scripts have failed because there is an issue in the VUGen, okay, VUGen script, I mean the issue because you haven't checked it properly in the VUGen, then you have to stop the whole test. You have to fix the issue in that script, and then you have to rerun the script. And you have to rerun the script. So for the same reason, guys, a shakedown test or a dry run test is usually recommended before the actual test. Okay, let's say this particular script has failed while you are executing, where all the 50 scripts have been uploaded into the controller, you are executing, and the statement history script has failed. Let's say this particular script has failed. So the whole test now is going for a wait. So the whole test is a problem. So this is the reason why all your efforts is being wasted. So this is the reason why you have to do something called a shakedown test or a dry run test before the actual test, before the actual 1 hour test is done. Okay, before the actual 1 hour test is done, you have to do this shakedown test or a dry run test. Now let's try to understand what is this shakedown test or a dry run test. Okay, this is an interview question, guys. Sometimes people would like to ask you, if you have done any mock test or a shakedown test or a dry run test. Okay, you see, as the name suggests, okay, it is a mock or a sample test which is executed before the actual test. Before the main actual test, a sample or a mock test will be executed. If you are coming from a manual testing world, if you're coming from a manual or a system testing world, people usually call it as a smoke test or a sanity test in that world. So this is similar to the smoke test or a sanity test, but we don't call this as a smoke test or a sanity test. We call it as a shakedown test or a dry run test. So it is a mock test, it's a sample test, okay, before the actual test is done. Okay, so let's say the actual test is being executed with 2 scripts with 1000 concurrent users. Let's say that is what the actual test is. What we do the shakedown test with? Now we run these 2 scripts. But we run it with 50 concurrent users only, not with 100 concurrent users. Okay, so let's say the actual test is, this is what your actual test is. Check mail and delete mail. You're supposed to run this one with 600, this one with 400, overall 1000. This is what your actual test is. But what you do as a part of the shakedown test, okay, you just run this with 30 users, run with this 20 users. And this one usually we run it for 1 hour. Okay, this one usually we run it for 1 hour, and this one we don't run it for 1 hour. We run it for 10 to 15 minutes. That's it. Okay, that should be enough. And why are we running this shakedown test or a mockdown test? Because of various reasons. Okay, so purpose of this test, we need to make sure all my scripts are working fine. In this case, there are only 2 scripts. Okay, 2 scripts are working fine or not. Okay, is my performance testing environment up and running and not having any issues? So we do our performance test in our own environment called performance testing environment. So we need to make sure our environment is good or not. So by doing this shakedown test, we would know our performance testing environment is good or not. Okay, and we need to make sure there is no issue with the data and there is no issue with the LGs. So we run this test with certain LGs, right? We need to make sure these LGs are good or not. Okay, so these LGs are good, the performance testing environment is good, the data that you use for the script is good, and the scripts are working fine. We need to make sure all this is good, so that then you can go with the actual test. Then we can go with the actual test. So this is the purpose of the shakedown test. So Anita is asking a question, how do we know if there is any issue in the data? Do we get access to the database? No. So the data that we are talking about, there are two things, Anita. The data that we are talking about is the data that you give to your scripts. Okay, there is a concept called parameterization. As a part of parameterization, you give some data to the scripts. Okay, for example, Anita, there is a login script that you have created. So what you do what you give as an input to the script is some data, username, passwords. Okay, you might give some 100 username passwords to the script, so that every time it will log in with a different username and password. Okay, let's say there is a registration script. Okay, what you give as an input to the script is the first name, last name, email address, phone number, and all that. So you give a lot of data as an input to the script. So we are talking about the data that you give as an input to the script. Okay, and and as you said, Anita, the data could be coming from the database as well, but that will be an environment issue. If there is a data in the database that is incorrect, then that will be an environment issue, and even then the script will fail. Okay, once the script fails, now you have to figure out as to why the script has failed. Is this a problem with the script, the way you have recorded the script, or the code that you have written, or the data that you have given input to the script, or the data which is there in the database is a problem? So you have to troubleshoot that. Okay, so Parmesh has a question for us. Whenever SLA you mentioned here is 2, 5, 8 seconds are standards for the application, or you're mentioning as an example. I've given that as an example, Parmesh. Okay, so it's not the standard, okay, that you get as a part of NFR gathering. If you have looked at my previous class, the very first stage is NFR gathering stage. Okay, the PTLC, in PTLC, the very first thing is the NFR gathering stage. As a part of NFR gathering phase, the client will give you the SLAs for your application. Okay, whether it is 2, 5, 8, or it is 2 for all the functionalities, or whether it is 5 for all the functionalities, he will give. It completely depends on the application. And from your side, all you have to do is whatever the results you get, you compare with the SLAs. Parmesh, have I answered your question? Okay, thank you. So just give me 1 moment, guys. Let me grab some water. Hang on 5 minutes, please. 1 minute, please. Sorry about that, guys. Next, Anita has asked a question. What if there is no SLA defined in the NFR? Is it possible to have the SLA? Anita, this is the thing. Okay. In the first stage of PTLC, when you gather the NFRs, as a performance tester, you look at the NFRs. You are the one who will gather it. Okay, honestly, you or your manager or your lead, okay, will be gathering the NFRs, and you should know what is that requirements you need. And you will be, it's not just, don't assume that it will be provided by somebody, and if something is not there, it's not your mistake. No, this particular stage, you are the one who will gather it. You are the one who makes sure that you have all the NFRs that you wanted. And in one of the chapters, I will cover what all the NFRs that you're supposed to collect. Okay, if this information is not there, then it's your problem, it's not his problem. Okay, and there is a formal sign off which happens as well. So once the sign off is done, which means that you are happy with the NFRs and the client is happy with the NFRs. So if the sign off is done and you don't have the NFRs, then it's your problem. At this point of time, again, you have to go and get the NFRs from them, which is not appropriate. Okay, there is some time which has been allocated for that, and you have to do your job right. Okay, if you have done your job right, you would have gotten all the NFRs that you needed, which is also the SLA. Okay, Anita, are we on the same page here? So when I said you, I think it should be your team, typically the manager or the lead who is supposed to get all this information from the client. Okay, so now the last component, we have discussed about two components, right? One is the VUGen part and the other is the controller part. Let's look at the last part, which is the analyzer. Okay, so this component will provide the results. Okay, so once the test is done, you have created the scripts using VUGen, you have executed using the controller, you have the results, and the results can be analyzed using the analyzer or analysis. Okay, earlier it used to call it, the component was called as analyzer, but these days we are calling this component as analysis. Okay, on further analysis of the results, one can identify performance bottlenecks of the application under test. So we use this particular component to actually identify the bottlenecks, if there are any. Not necessarily every application will have the bottlenecks, guys. Okay, there are so many times wherein I didn't find a bottleneck. Okay, so if there are any bottlenecks, this is the component of the LoadRunner which will help you or assist you to identify the bottleneck. And finally, the test report. Once the test is done, okay, there should be some report. This report can be generated using this component called analyzer or analysis. How we can do that, all that we will look into it one by one. Okay. Now, hang on guys, 1 second. There are some slides which I wanted to add it over here, which is related to the LoadRunner. Just give me one moment, please. Okay, so guys, Anita is asking a question. If response times of any transaction in the test results is more than SLA, then is that considered as a bottleneck? Okay, Anita, here is the thing. Bottleneck is there, that's why the response times was high. Okay, so the response times being less than the SLA is not the bottleneck, since there is a bottleneck in the system because of which the response times are less than the SLA. Usually in the real-time projects, we have 50 to 60 scripts, and each script could have 4 to 5 transactions. So overall in a test, you could have close to 100 to 200 transactions, or 100 to 200, yeah, so transactions. So some of them haven't defined what is a transaction yet, haven't defined what is a response time yet, guys. So for them, just ignore these questions. Slowly as I go forward, I will introduce these terms called transactions and response times. But for now, just assume that transaction is your functionality, response time is how fast your application is. Okay, so the guys who are still, who are there, okay, just assume that transaction is nothing but your functionality or the business process, and response times is nothing but how fast and how slow it is. Okay, but slowly I will introduce these terms called transaction and response times in my coming classes. But since Anita Chaudhary has asked this question, let me answer this question. Okay, so out of these 100 200 transactions that you have in the test, if there are a couple of or few of them transactions are going over the SLA, nobody would actually care about it. Okay, I'm telling you honestly. Okay, but out of these 200, if there are 10 or 15 transactions which are going over the SLA, and that too by lot. Okay, for example, the SLA is 2 seconds, it is going over, let's say, 2.1 or 2.2. Okay, nobody really cares. Okay, just because of 2 it is 2.1, it's not a big deal, Anita. And one more thing, this time around you're running the test 2 times. This time around is 2.1, and the next time around when you run the test it would be 1.9. At different points of time the servers will behave different ways, so you get little bit of difference all the time in the response times. 10 to 20% of the difference is always there. Okay, but the response times is high, and it's really high by lot of, by a huge margin. For example, the SLA is 2 seconds and you got like 2.6 or 2.7, and that too not for one transaction but for, let's say, quite a few transactions, then you are worried about. Okay, then you're worried about, and this is when people start looking at the bottleneck. Because of single bottleneck, all these transactions could be affected. Okay, or you could have multiple bottlenecks. Okay, but typically you would have one bottleneck and multiple transactions will be affected. It's not like 10 transactions are going over the SLA, so you have 10 different bottlenecks. No, the 10 transactions are going over the SLA, and that too by a far margin. This is when people start thinking about it and wanted to do the bottleneck analysis and want to fix it. And it could be because of one bottleneck, all these issues could have happened. Okay, so you start thinking it's not a manual, or in a system testing world, you have 10 defects, you report the 10 defects, and there could be 10 different fixes for it. Here there are 10 transactions going over the SLA, it could be only one fix which will take care of all that. Okay, so Anita, are we on the same page, or should I go again? Okay, wonderful. Okay, so this is a different world, Anita. You see, performance testing is a different thing. Even one bottleneck, I will tell you one example what happened in one of my project. Okay, so we were executed the test, and there were close to 300 transactions, okay, in that test, and we were looking through all the 300 transactions. At least there were 20 to 30 transactions which are going over the SLA, and 10 of them by far margin. Like 2 seconds were there. 2 seconds was the SLA. It was 5 seconds for few. Response times was 5 seconds for few of them, and 9 seconds for few of them. Okay, so this is when people were not happy, and then you need to find the bottlenecks and you have to fix it. So my team looked into as to identify what is the bottleneck, couldn't do it. The development team spent a lot of time to understand where it is, couldn't do it. It passed on, the bug was passed to database team, because they kind of figured out that it is in the database, but nobody knows. Our team also identified that the problem is in the database. Okay, but we couldn't pinpoint the issue as to where in the database this bottleneck is. Okay, development team couldn't do it. The database team, struggled for 10-15 days. They couldn't find it. Okay, then it went to other team. Finally, there was a senior performance engineer from Infosys, and he happened to look into it, and he could find it in just 3-4 hours. He could find this issue and say that this is the issue, 100% this is the issue. Then the fixing takes 2 to 3 minutes. I mean, if you find the issue, just about changing some settings, changing some queries and all that, they could fix it in few hours. And after fixing, we reran the test, and the results were actually very, very good as compared to before. It was some SLAs were some of the transactions were still going over the SLA, but not by far margin, like 2.4, 2.6, 2.8 or something like that. Okay, so everybody was happy, and we have closed this thing. So identifying the bottleneck sometimes is not a piece of cake. Even though it's one bottleneck, it takes sometimes months together. I've seen some applications. Okay, and sometimes these queries will create such a huge bottleneck. So I'll give you one instance. Okay, so we have created the script using Vugen, and we were executing the script using Vugen. And with Vugen, you can only execute with only one virtual user, Anita. Okay, so we were creating the script and executing the script with one virtual user. The response times were really bad. Okay, so like it was like 3 seconds, 4 seconds, and 5 seconds. Okay, the response times only with one virtual user. Okay, then we understood that with one virtual user the response times are so bad. Now you upload it into the controller, you run it with multiple virtual users, the response times will be even further bad. Okay, then we immediately send the results to the developer saying that we haven't executed the test with multiple virtual users yet, but with single user only, this is the performance which is pretty bad. Okay, then they have identified the root cause. We were continuing our scripting part. Okay, they were looking into the issue, and they have changed one query. Okay, it was one query because of which the response times were so bad. Okay, so the response times were almost 9 seconds, 10 seconds. Okay, so the query, I think they haven't used the joins well. Okay, so and the indexing was also not done properly. So what I heard from the development team is they have changed some indexes and they have added few indexes to it. Okay, so once the indexing is done right on a particular column in the database, the response times were as low as 0.5 seconds. Something which were in the order of 9 and 10 seconds fell back to 0.5 seconds just by adding the indexing. So like this, multiple instances will be there. So Anita, are we happy? I mean, I'm sharing some real-time instances as to what happened in my project. You got an idea as to what we are talking about when we talk about bottlenecks? Okay, yeah. So in my experience, most of the bottlenecks actually come from the databases. It is because the indexing is not done properly. It is because the primary key was not identified properly. It is because the queries were not written efficiently. Typically, most of the bottlenecks will be related to that. Okay, and we worry when the response times are really high. Okay. Let's look at architecture of LoadRunner. Okay, how this LoadRunner architecture is. Okay, if it was only one component, then there is no architecture. Why worry about it? But you have more components. Let's understand the architecture, and lot of interview questions will be in and around this LoadRunner architecture, guys. Will be in and around this LoadRunner architecture. Okay, so let's try to understand the architecture of Microsoft Office. Why I have taken Microsoft Office? Because every system has this Office, right? Whether you want it or not, every system will have this Office because you wanted to use the Word, Excel, PPT and all that. What is the architecture of it? It is very, very simple. You buy this Microsoft Office, which is a software, you install on your client machine. And this Microsoft Office is there on this client machine, and that's the architecture. That's it. It's very simple. The whole package is installed on your client machine, and whenever you want it, you open it. So the architecture of Microsoft Office is very, very simple. You take a machine which is a desktop and you install the software of Microsoft Office on that, and we are good to go. Okay. Okay, so this is as simple as that. Okay, the architecture of Microsoft Office. Okay, so everything is installed on only one single desktop or one single machine. Okay, we call this as a client machine, by the way. Okay, so that's as simple as this. But LoadRunner is not something like that. You take the software of LoadRunner and install on one machine. No, it's not as simple as that. It is little complicated than that. Let's look at that LoadRunner architecture. As you can see here, okay, so you see here, okay, so there are, as I told you, there are four components: ViewGen, controller, analysis, and load generators. Okay, and LG machines. You see LGs. Okay, so there are so many components. You see ViewGen, controller, analysis, and load generators. Okay, and this is your application under test. Let's say you're testing the Gmail application, then this is related to the Gmail application. What is this web server, app server, database server? We'll look into it in detail when we discuss about the software architecture, but assumes that this is your application under test. In this case, let's assume it's a Gmail application. Okay, so let's see how these components will interact with each other and your application. Okay, this is your application, Gmail application, and these components are belonging to the LoadRunner, and this is your application under test. So how these components will interact with each other, we will look into it. Not only that, okay, we'll see the architecture of it, as in where this ViewGen is installed, where this controller is installed, where this analysis is installed, where these load generators are installed. We'll look into all that. But for now, let's assume there are two load generators. Okay, you can have as many as we wanted. Okay, so in this picture, I've included only two load generators. Okay, now let's see what happens. Okay, let's look at the whole process, the whole PTLC, but from the LoadRunner angle. We're looking at the performance testing lifecycle, but from the LoadRunner angle. Okay, first, as a performance tester, what do? You create two scripts. We have been talking about the same scripts, checkmail scripts and composeMail scripts. Let's say we have created these two scripts called checkmail scripts and composeMail scripts. We create these scripts in the ViewGen separately, and we record it, not script it from the scratch. We will record these two scripts. Okay, and we execute these two scripts separately to make sure the scripts are working fine. Now you upload these two scripts into the controller. You upload these two scripts into the controller. This is when you have these two scripts over here. Now in the controller, you will create this test scenario. Test scenario means for checkmail, how many virtual users are supposed to be, and composeMail, it's supposed to run with how many virtual users. Not only that, you will say these 600 users are coming from which LG, these 400 users are coming from which LG. You have to tell them. Here you told to the controller saying that these 600 users are coming from LG1 and these 400 users are coming from LG2. Now this whole scenario is executed. Now a whole scenario is created. You click on the run button. Okay, you click on the run button. Once you click on the run button, this checkmail script will be downloaded onto the LG1 machine. Okay, because you said the checkmail script, these 600 users are coming from LG1, so this checkmail script will be downloaded to the LG1 machine, and the composeMail script will be downloaded onto the LG2 machine. Because you said when you configured the scenario in the controller, you said this should be in the LG1, this is the LG2. Okay, so checkmail is downloaded to LG1, composeMail is downloaded to LG2. Now 600 users will be created by LG1 and 400 users will be created by LG2. Now these 600 users will be continuously executing the checkmail. These 400 users will be continuously executing the composeMail. Okay, as we execute, the request will be sent to this application under test by the LG1, and the request will be sent to this application under test by LG2. Okay, so once the test is done, the results file will be created by LG1. The results file will be created by LG1 and it will be sent back to the controller, and results file will be created by LG2 and that will be sent back to the controller as well. Now as a performance tester, I don't want to see these results separately. So what do we request the controller? To merge these two results. This merging, there is a special word in performance testing or LoadRunner. We call it as collating. We call it as collating. Okay, the collating will be automatically done by the controller. If you haven't touched any of these settings, collating will be automatically done by the controller itself. Once the collation is done, you will have one collated results. One result for all the LGs. Let's say you have 10 LGs. All the results from the 10 LGs will be collated over here. The collated results can be looked in by the performance tester by the tool called analysis or analyzer. By the tool called analysis or analyzer, we will be able to look at this collated results. We will be able to make sense out of these results, and we will be able to do the performance bottleneck analysis from this collated results. This is how the LoadRunner architecture is, guys. Okay, any questions? You want me to repeat it? I'll do it. Any questions you can ask me at this point of time. This is extremely important for you to understand the LoadRunner architecture. There will be a lot of questions around it. Okay, I'll ask you a simple question. If you say that you have understood all of it, I'll ask you a simple question. Okay, I have some questions coming in. I'll take the questions and then I will ask one question. Okay, Parmesh says repeat it. Okay, let me quickly repeat this again. Okay, overall. So Parmesh, is there something that you haven't understood or nothing you have understood? Parmesh, there is a certain point in here that you haven't understood or you haven't understood any of it. Parmesh, can you please let me know? Okay, okay. So let's do that. Let's do that. Watch here, guys, carefully. Okay, so there is VueGen, there is controller, analysis, load generators. These are all the components of the load runner. Okay, 4 different components of load runner. We have been discussing about these 4 components of load runner. Okay, and this is your application under test. Okay, this is your application under test. Okay, let's take it's a Gmail application. So this has nothing to do with, don't try to understand what is this web server, app server, database server. We'll get to that later. But for now, let's assume that this is your Gmail application and let's not worry too much about it. Okay. So this is your first component. Using this first component, you have created these 2 scripts called checkmail and compose mail scripts. Okay. You have created the scripts, you have executed the scripts, you made sure the scripts are working fine. Now at this point of time, you upload the scripts into the controller. Now you see the scripts have been uploaded into the controller. In the controller, you will create the test scenario. You have only 2 groups over here now. Okay, group 1, which is a checkmail group, group 2, which is a compose mail group. When you create this scenario or the groups, you have to tell how many virtual users you have to run with checkmail. Let's say you have to run it with 600 users, you plug in that number. But you have to also tell to the controller where these 600 users are coming from. These 600 users are coming from the component called LG. The compose mail, let's say you wanted to run with 400, you plug in that number and you have to tell to the controller where these 400 are coming from. These 400 are coming from the LG2. Once this whole scenario is ready, you click on the run button. As soon as you click on the run button, the checkmail script will be downloaded onto the LG1 machine. The compose mail script will be downloaded onto the LG2 machine. Now, checkmail needs to be executed with how many? 600 virtual users. So the LG1 will create the 600 virtual users. LG2 will create the 400 virtual users. So these 600 virtual users will be executing the checkmail. This 400 will be executing the compose mail. As you execute, the request will be sent to the application under test and we get the response back. Same thing with LG2 as well. Okay. Now, once the whole test is done, you will have the results. The results will be generated by the LG1 for this checkmail. The results will be LG2 results will be created by LG2. Okay, for this compose mail script. Okay. Now these LG1 results, LG2 results will be sent back to this controller by the LGs, or the controller will pull this LG1 results and LG2 results back. And as a performance tester, I don't want to see these results separately. I wanted to see one single result. So the controller will merge these 2 results, or merging is what we call it as collation or collated. Okay, so once the collation happens, you will have one collated results, and this collated results, you can look at this collated results using the tool called analysis. Using this tool called analysis, you will be look at the collated results at once. This is what the LoadRunner architecture is for Mesh. Okay, there's a lot of, so Ruxana has asked, what language do we use for creating the scripts in Vusion? Ruxana, Martin, we use C language. Okay, the Vusion supports two languages. One is C and one is VB script. I haven't seen people using VB script ever again. I mean, never in my life. I've been in the industry for a while. Okay, and it's been added recently as well. Okay, VB scripting. So C is predominantly used. It's been there for last 20 years, as long as LoadRunner tool is there, C language is there. So a lot of people have started with that, they stick to C, and new people are also using the C. Haven't seen people using VB script as well. Okay, so I would suggest go with C itself, because there's a lot of help available on the Google, internet, everywhere else as well. Okay, Ruxan, I hope I have understood. Parmesh, I think I have repeated and you have understood the second time around, I believe. Okay, so hope so. Anita has asked a question. Can we use only one LG instead of two? How do we know how many LGs do we use? Anita, we have separate slides for that. I'll try to complete that today. Okay, I have separate slides for that. Hold on to the question. Promise I'll cover that as a part of the course. Okay. Now, okay, where do we install? Okay, where do we install all this? Okay, so where do we install all these components? Okay, so you see this Vusion is installed on the performance testers machine. Okay, that is your machine. Okay, when you go to a company will provide you a computer, right? On that computer you install the Vusion. Typically I'm saying, okay, so it will be the performance testers machine. Controller, a separate Windows machine. Okay, we call it as a controller machine. You install this component called controller on a separate machine, and we start calling it as a controller machine. Okay, so separate machine. We use a separate machine, let's say machine 1. Okay, you identify any desktop or any virtual machine that the company will give you, install the controller on it, and that becomes the controller machine. Okay, analysis is also on the performance testers machine. Okay, so Vusion and analysis is installed on your machines. Okay, controller is installed on a separate machine, and Vusions or the load injectors are installed on separate machines. So let's say LG1 is installed on machine 2, LG2 is installed on machine 3. Okay, you have as many LGs, you have as many machines. So this machine M2 will be called as LG1 machine, and this machine M3 will be called as LG2 machine. So controller will be on one machine, LG1 will be on one machine, LG2 will be on one machine. If you have LG3, that will be on one machine. If you have LG4, that will be on one machine. If you have LG5, that will be on one separate machine. Typically these are all Windows machine. If Windows 7 or Windows XP or Windows whatever you have, it is fine. Okay, the LoadRunner supports all of them. But analysis and Vusion will be installed on performance testers machine. Controller will be on separate machine, and LGs will be on completely different machines. And this is what we have in a real-time setup. When you go to the company, this is how it will be. This is how it will be. Okay, why the controller is installed on a separate machine means, okay, you will have only one license. Typically they don't buy too many licenses. You have only one license, which is why you have only one controller machine license. Okay, but you can have as many Vusions and analysis as well. Let's say there are 5 performance testers. Okay, you can have 5 Vusions and 5 analysis. So these 5 Vusions and 5 analysis are installed on 5 different performance testers. But you can have only one controller. That is the reason why you will have a separate controller machine. You have a separate controller machine. Sorry. So you have a separate controller machine. One machine is allocated to that installed controller. Now all the 5 performance testers have to share this controller machine. Whenever they have to run the test, they have to make sure none of the 4 are using, and they have to use this. Okay, because of the licensing issues, you cannot have 5 different controllers. You can have only. But in my place there has been a huge rain yesterday, and internet has been having some issues. So luckily I have a backup internet, so we are able to continue. So sorry for that particular part. Let's get started as to where we are right now. Okay, and I hope you had a break as well. So Now we understood, like, how these components are installed in the real time. Okay, so we have discussed that the Vusion will be installed on the tester's machine, and the controller is installed on a separate machine. Like, you take any desktop or any machine and you install the controller on it, and analysis will be on the performance tester's machine only, and LGs will be on two different machines. And here I have two LGs, so two LGs are installed on two different machines. Okay, this is what happens in the real world, in the real-time setup. We have discussed this before the break, but now for our session, okay, what is the setup? Okay, so this Vusion is installed on your desktop only, the desktop with which I am sharing the screen and all that, and the controller is also installed on your machine only, and analysis is installed on your machine only. And for our setup, we have only one LG, which is LG1, okay, which we call it as load injectors or agent machine as well. Okay, that is installed on my machine, on your machine. Okay, note we have only one LG machine installed. Okay, on our machine. Okay, we have only one LG machine. Okay, not two. We just have only one machine, which is a local host machine. As we proceed further, we'll see how to use that LG machine. But at this point of time, you need to know that every single component is installed on your desktop, and you have only one LG which is available on your desktop. But in the real-time setup, it is completely different. It is completely different. Okay. Now we'll get into the load generators. We'll try to understand what is this load generators in detail. Okay, we have seen that the virtual users are coming from this load generators, but we'll try to understand what is this load generators. And our Anita is also asked a question as to how many LGs we need, all the time it's two, or how it will be and all that. We'll get to that question as well. Okay, now we know that if you have two LGs, you need two machines. If you have three LGs, you need three machines. If you have one LG, you need one machine at this point of time. Okay, but we'll try to understand why we need two or three or four. Okay, so load generators are the systems that will create the virtual users. We understood that. Okay, depending on the hardware configuration of LG, number of virtual users generated by the LG changes. Okay, for example, if the hardware configuration is less, the LG is capable of giving only few virtual users. If the hardware configuration of LG is good, the number of virtual users that will be generated will be more. Okay, so depending on the hardware configuration of the LG, the number of virtual users coming out of the LG changes. Okay, when I said hardware configuration, what am I talking about? Which processor, what is the RAM, what is the hard disk? Mainly depends upon the RAM. Okay, your RAM. So let's look at that. Okay, what is the LG machine? Okay, LG machine is the one which will create the virtual users. Okay, these virtual users will act will act as a real, are replaced the real users. These virtual users replace the real users. And what is the LG machine? LG machine is the one which will create this virtual users. The virtual users are coming from this LG machine. Okay, so calculation of the LG machines. So how do we know how many LG machines we need for my project? Okay, so let's say, okay, you have taken this machine. On this machine, you have installed the LG software on that. You have installed the LG software on that. Now this became an LG machine. I've taken a desktop. On that desktop, you have installed the LG software, and that became my LG machine. And what is the configuration of it? Let's say this 2.3 gigahertz processor, 500 MB RAM. This is what I'm interested in. 500 MB RAM. Okay. So now this machine is the LG machine. Okay. Okay. Now, so the number of virtual users this LG can support totally depends upon something called memory footprint. Okay, this is the LG machine. How many virtual users that this machine can give? It totally depends upon the memory footprint. It totally depends upon the memory footprint. Okay, so it's an interview question, guys. Okay, so it's an interview question as to, they will ask you, how do you calculate the number of LG machines required for your project? Concentrate here. Okay, so again, a memory footprint will vary from protocol to protocol, and it will vary from tool to tool. Okay, so let's assume we'll take one single protocol, which is HTTP HTML protocol. Okay, so all our scripting will be done on this protocol. So let's assume HTTP HTML protocol is what it is, and the memory footprint for this protocol is 2.3 MB. Okay, for each virtual user, how much RAM it requires? 2.3 MB of RAM. Okay, so the memory footprint for this protocol, which is HTTP HTML protocol, is 2.3 MB for each virtual user. For each virtual user, you have 2.3 MB of RAM is required if you are considering HTTP HTML protocol. Okay, now how much RAM you have on this machine? You have 500 MB RAM. For each virtual user, how much is required? 2.3 MB. So how many virtual users it will support? Okay, so let's say 2.3 MB is one user, 500, how much X? Okay, so X multiplied by 2.3 is equal to 500 multiplied by 1, 500 multiplied by 1. 2.3 multiplied by X is equal to 500 multiplied by 1. X is equal to 500 divided by 2.3. So you have 217.3. You cannot have 0.3 users. So this LG machine will support how many virtual users? 217 virtual users, assuming that you are using HTTP HTML protocol. For example, now the test needs to be done with 1000 virtual users. Okay, now the test needs to be done with 1000 virtual users. So how many LG machines you need, guys? How many LG machines you would need? Assuming that the test needs to be done with 1000 virtual users. So each LG is supporting 217 virtual users. How many LG machines you would need? How many LG machines you need? Parmesh says 5. Yes, you would need 5 LG machines. Each one is supporting 217. If you take 4, it will be somewhere around 840. So if you take 5, it will be more than 1000. So we will need 5 LG machines. Okay, so it totally depends upon the memory footprint, guys. Okay, and this memory footprint will change from protocol to protocol, tool to tool. Let's take, we are into LoadRunner only, so let's not worry about tool to tool. Let's worry about the protocol to protocol. I'm telling you, HTTP HTML protocol, the footprint is 2.3 MB. Okay, so if your LG RAM is 500, so it will support approximately 217 virtual users. Okay. Okay, so for our test now, we have 1000 virtual users, right? So for our test now, you have 1000 virtual users. Okay, so for one LG can support 217. For 1000, how many LGs you need? You need 4.6 LGs, but you cannot have 0.6 LGs, so you need 5 LGs for my project. Okay, so you have LG1, LG2, LG3, LG4, LG5. Now let's look at the scenario. Checkmail needs to be executed with 600. So you need 3 LGs, LG1, LG2, LG3, and delete mail needs to be executed with 400. You need 2 LGs, LG4 and LG5. So total you have 5 LG machines for my project now. You have 5 LG machines for my project now. Okay. So now, okay, before I go any further, you have any questions over here, guys? You have any questions over here? Anita, is your question answered here? Anita, are you still there? So this is how you do your calculations, and most likely than not, they will ask this as an interview question as to how did you come out with that? How did you know that you need so many LGs, or how many LGs you have need, how many LGs you have used, and why you have used more than one? They might ask you in any different way, but the answer is same. The LGs will support only certain number of virtual users, and that certain number will come. You will come to that certain number depending upon the RAM of your LG and the memory footprint of the protocol. Okay, for example, I've told you if you have a 500 MB RAM and the memory footprint is 2.3, which is for the HTTP HTML protocol, it will support approximately 217 virtual users. And if you are running the test with 1000, you will need 5 LGs. You will need 5 LGs. Okay, in the scenario, you can set up multiple LGs as well, not just LG1. You can have LG1, LG2, LG3. You can define in the scenario. Okay, so this is how you come to the conclusion. Load generators. So now the controller, by the name itself says it controls. The controller it's controlling what? It is controlling the scripts. It is controlling the number of virtual users. Not only that, it is controlling the LGs as well. Okay, this is the one it will control the multiple LGs. Okay, so that's why And you also observe that each group has a multiple LGs. This is also a possibility. Okay, or sometimes you can have multiple groups can have the same LG as well. Multiple groups have the same LG as well. Okay, this is a possibility as well. Okay, this is a possibility as well. Okay, but one thing you need to know is, okay, let's say you wanted to run the test with 1000 users and you have 5 LGs. Everything is good, but not only that, you need the license for 1000 as well. Just because you have 5 LGs which will support 1000 users is not good enough. You need to buy the license for 1000 LGs as well. Okay, you need to buy the license for 1000 LGs as well. This is extremely important, guys. This is extremely important. Okay, let's look at the basic LR flow. First, you plan the test, you create the virtual users, then you create the scenario. This is what I've been talking about in the whole class. I've put that as summarized the whole thing, guys, for you. First, you plan the load test using the NFR documents. Then you create the virtual user scripts. Then you create the scenario in the controller. This is what happens in the ViewGen. You create the scenario in the controller. You execute the scenario in the controller, and finally you analyze the results in the analyzer or analysis. Okay, so when we create the scenario, this is what we are talking about, creating the scenario. Okay, you create the scenario, you execute the scenario, and finally you get the results. You look at the results in the analysis. Okay, if you find an issue, you identify the bottleneck, you take away the bottleneck. And identifying the bottleneck and taking away the bottleneck, they also call it as performance tuning or tuning the system. Identifying the bottleneck and taking away the bottleneck, there is a name for that. We call that as a performance tuning or tuning the system. Okay, so they tune the system or they take away the bottlenecks, and once that is done, you run the test again, you analyze the results again, and if you don't have the bottleneck, you finally create the reports. You finally create the reports and send it across. Okay, that's what you do. Okay, Parmesh, which phase will take more time? We use the scripting. It depends, but usually it's your planning. You plan accordingly how long you want it. But typically your test lead, depending upon the number of the script, will give maximum time for the scripts or test design phase wherein you create the scripts. Typically it will be for 1 month. Okay, depending on the scripts. For example, in my latest project, I have 2 people working for me and the number of scripts were 50. So I've given 1 month for them to create 50 scripts. 25 by first person, 25 by second person. Okay, execution you usually give 15 to 20 days, analysis 15 to 20 days, and remaining phases 15 to 20 days. Okay, so on this note, we will close today's chapter, guys. In the next class, which will be not the demo sessions, which will be the real sessions, we'll look into how to install the LoadRunner, and we'll look into the architecture, which is extremely important for any performance tester, and then we will start looking into the tool. Then we'll start looking into the tool and see how the tool works, how to create the scripts and all that. Okay, if you have any questions, I will be here to take your questions. Okay. Any questions, guys? So Parmesh, it will be the same timings, which is 6:30 to 8:15. Sometimes it goes over 8:15 as well. Okay, 8:50. So it's, I would say 6:30 to 8 a.m. India time, if you're talking about IST. So Ashna, would you be able to answer that? I think that is right, Ashna, right? The timings will be same, right? 6:30 to 8:15. Ashna, are you there? Yeah, that's what it is, Parmesh. The classes will be from 6:30 to 8, and assume that sometimes it will go over 8 as well. Depending on the doubts, depending on the topics we are covering, sometimes 15 minutes here and there. Okay, guys, thank you so much for joining. I hope to see you in the actual classes when they are starting next week. come back with a lot of energy. There's a lot of learning to do. Okay. Thank you so much for Anita, Ruxana, Parmesh, uh, uh, Jin Chen, Arun, Mohanty. Okay. Thank you for joining in. Bye bye. Take care. See you.